Okay, we're going to take a look at what exponents are. Exponents, the definition is a number that tells you how many times a base is used to multiply itself, really. We have an example here. 5 to the third power is how we say that. 5 is the base, 3 is the exponent. So you multiply 5 times 5 times 5. Okay, what that tells me is when we say 5 is the base, that's the big number. Okay, now, first of all, two kind of key things you need to know here. If you just wrote any number, I wrote a 5, if you wrote a 37, it automatically has an exponent of 1. If you don't write an exponent, everything has an exponent of 1. And anything to the first power is that number. 5 to the first power is 5. 6 to the first power is 6. 7 to the first power is 7. Okay? One little tip too. Anything to the 0 power is 1. So if I had 5 to the 0 power, that is actually 1. 6 to the 0 power, that's 1. 7 to the 0 power is 1. So there's our two exceptions, or two weird rules. Now, but we're talking about 5 to the third power. What that tells me to do is 5 is my base, and I'm going to write it 3 times. 5 times 5 times 5. Okay, and then I'm going to multiply that out. 5 times 5 is 25, and this answer times one more 5 in order to get my answer. Okay, when I multiply that out, I actually get 125. If this was 5 to the fourth power, I would add another 5 out here. Okay, so let's continue to look at that, whatever our base is. Here we have a base of 3 to the first power, which is 3. Now, if I added a couple here, let's go 3 to the third power. Okay, what that means is I write 3 times. 3 times 3 times 3. 1, 2, 3 threes. And I'm going to multiply that out, and eventually I would get 27. Let's say it wasn't 3. Let's say it was just 2. 3 to the second power. Okay, I need 2 threes. I have one too many here. So I have a 3 times 3, okay, 2 threes, and I'm multiplying this together. 3 times 3 is equal to 9. All right, and you see, no matter how many the exponent, like if I had 3 to the fifth power, that means I have to write out 3 5 times and multiply them all together, just 2 at a time. 3 times 3 is 9, times 3 is 27, and I keep going, and 3 to the fifth power, this is telling me that it's 243. All right, so if we evaluate this looking at our cool magic tunnel here, I have 4 squared, or 4 to the second power. How many 4s do you think I'm going to have here? Well, I'm going to have 2 because there's a 2 there. And so what I have when I go through the magic tunnel is 4 squared is the same thing as 4 times 4 because there's 2 4s here. All right, that was our exponent. 4 squared. 4 squared is the same thing as 16 because it's 4 times 4. What about if we have a base of 2 to the fourth power? Well, this tells me there's going to be 4 2's involved. Put this through the magic tunnel. We can see there's accidentally an extra x there that shouldn't be there, so I'll sort of pretend that's not there. But because it was 2 to the fourth power, that tells me there's 1, 2, 3, 4 2's. Well, multiply these together. 2 times 2 is 4. 4 times 2 is 8, and I got to make sure I keep track of these, so sometimes I like to cross them out. And then 8 times 2 is 16. All right, and no matter what the base is, like this one we have a base of 6. How many 6's do you see? Okay, well, let's see, I see 1, 2, 3, 4. Okay, this tells me it's the same thing. 6 times 6 times 6 times 6 is the same thing as 6 to the fourth power. This one is going to be 7 to the 1, 2, 3, 4, fifth power. 7 to the fifth power. And then we can multiply these out 2 at a time. 6 to the fourth power is 1,296. These are big numbers. 16,000 for 7 to the fifth power. What about this one? Well, we see we have two 11's, so it's 11 squared, or just 11 to the second power. And then to solve it, we multiply 11 times 11, which is 121. Let's just look at a couple of these. Well, first thing that stands out, I see this one, 1 to the fifth power. We didn't talk about 1. That means I write 5 1's and multiply it times each other. What happens when you multiply 1 times 1? 1 times 1 is 1. Okay, so 1 times 1 is 1, times another 1 is 1, times another 1 is 1. We kind of see a pattern here. 1 to any power is going to be 1. Let's look at number 6 here. 9 squared. That means I'm going to write 2 nines because the exponent is 2. 9 times 9, and 9 times 9 is 81. That's exponents. It's that easy.